Right, hello. What we're going to do now is reverse Polish notation. So you need the PowerPoint, you've got some notes here on that one, and you've got some exercises here. All right, plus you'll have some exam questions. Right, so let's start off with the PowerPoint. Now, reverse Polish and postfix. Now, reverse Polish notation, sometimes called postfix, and that will become clear in a minute. Now, what we use when we are doing mathematical notation, we use what's called infix. So we say 2 plus 2. So that's an operator, plus sign, and there's our operands here, 2 and 2. But there is an alternative. One is known is to put it in front, called prefix, and that is very similar to what we're doing when we're doing like an add instruction in assembly language. You have the add and then the operands, and the other one is postfix, and that becomes, the operator becomes at the end. So that's not 22, that's 2, then the number 2 again, and then the operator. So what that means is that we're going to be doing a plus on the previous 2 operands. Now it's called reverse Polish is because the person who invented it was Polish and his name was too hard to pronounce for most English speakers, so they called it reverse Polish, which sounds a bit mean now on the bloke who invented it. But there you go. Now let's have a look. Why use RPL and postfix? Well, again, it's talking about what that's why, very similar to what we're doing. We have opcode and operands, or so it's similar. I mean, postfix and prefix almost exactly the same, really. Now, the problem with infix. Now, there is a problem with infix. An expression like a times in brackets b plus c divided by d is taken to mean we do the brackets first, the b plus c, and then we go, right, we got an a times and a divide. Now, they're both the same precedence in terms of operators. So which one do we do first? Well, the associativity says we do left before right, so it would be a times that, and then we divide by d. Now that's a lot of working out for a computer to do. Now, the very first calculators that came out couldn't do all stuff like that. You'd have to do, and let me just show you an example. HP were the first people to bring sort of calculators out that could do that. Let me just clear. So what you would do is you would do that. This is a reverse Polish notation calculator. So if I want to add 2 and 2, so I'd enter 2, enter, then another 2, enter, and then I would press plus, and I get the answer 4 there. All right. So that is, now the thing about that is, if I put a complex expression in, it doesn't have to worry about any of the brackets. There's no brackets. It doesn't have any operator precedence. There's only one way to evaluate a reverse Polish expression. Only one way, right? And it doesn't require much memory, because all it requires is an answer, 2 operands, and then it does some maths and stores the answer again, right? So it's as simple as that. Now, this looks a lot worse than it actually is. I'll go through this. Now, what I'm going to do, I'll go through this example in a minute, well, on OneNote. So I suggest you either pause the video and then you, you open up the PowerPoint, so you've got this page, and then you can see my example. All right. Now, so I'm going to go to OneNote now. And I'm just going to do a really simple example. So there's our expression, 3 plus 5 divided by 4. All right. Now, we know that the 5 divided by 4 would happen first because of operator precedence. If we put that into C#, that's the way we would do it. Now, let's quickly go back to this. Now, it's got here, get first token from expression. Now, a token, everything here is a token. So that's a token, that's a token, that's a token. Everything's a token. All right. So but some tokens are different. For instance, that is an operand. That's an operand. That's an operand. Yeah. And this is an operator. Okay, so just know the difference between that. So our tokens can either be operands or operators. Okay, now let's go back to this. So the first thing is then is a nice, so we select current tokens, so we're just going to go and get tokens one at a time. And it can either be an operand, a bracket, I'm not going to do a bracket example, or an operator. All right, and then we're going to have to be using a stack, but it's fairly clear. Right, so I will switch back between the two. So that's probably the best thing to do. Now, the first thing it says is get first token from original expression. So our first token is here. So there's 3. Okay, so there's 3. And it says, right, if it's an operand, the very first case statement says if it's an operand here, then append it to new expression. So I just add 3 there to my new expression. That's easy, isn't it? Now I jump down now, none of those, end my select, get next token from original expression, then until reach the end of original. I haven't reached the end, so I just get the next token. Now this time I'm getting the plus. Now, so if I go down to here, it says case if it's an operator, which it is, it's a plus. If the stack is empty, then push it onto the stack. Well, the stack, we didn't even talk about stack, but there we go, there's my stack. It is empty, so I'm going to say push the operator onto the stack. All right, so it's now onto the stack. Get my next token, which is 5. Now we know that 5 is an operand, so I append it to my new expression. So it's 3, 5. That's not 35, that's 3 and then 5. Now the next thing I've got, my next token is an operator. So this is a bit more complex this time. So it says, right, if stack is empty, push item is not empty. Right, it says while the operator's precedence is lower than or equal to the precedence on the operator on the top of the stack, pop the item off the stack and append it to new expression. Right, now is my current operator less than or equal to? No, it's not. That's higher precedence than the plus. So what it says there, so we don't go into that while, we just push that operator onto the stack. Okay, so that becomes pushes onto the stack there. Okay, now so we now get our next one, which is a 4. Whenever we get an operand, then we just push it straight onto the stack. Sorry, yeah, that's right, operand straight onto the stack, so that's 4. Now we've read everything from we've finished this loop. It says while the stack is not empty, we pop items off the stack. So we pop, that's going to be the first, and then there's going to be a plus there. Right, so this 3 plus 5 divided by 4 in reverse Polish is 3, 5, 4, divide, plus. Now the way to read that is kind of like this. What you do is you basically find your first operator from left to right. So there, and then apply it to those two. So that'd be the first thing that would happen. And then what we would do, we would evaluate that and put the answer onto the stack. And then what we would do, so the answer of that would then be evaluated, if you like, with the plus there, all of that together. So we do the 5, 4 divide, which is what we'd expect to do. And then we would, the result of that, we would add to 3, which is good. Now, let me just flip that around so you can see a different example. So if we did 3 divided by 5 plus 4 this time. Right, I won't flip back this time. So the first thing is we've got an operand, so that's 3. That's good. Let's do a different colour. Okay, we have 3. Now we have a divide. Now we know the stack's empty, so we're just going to add the divide to the stack, which is good. Next thing we've got is the 5. Okay, now we've got an operator, a plus sign. Now it says if the stack is empty, push it onto the stack. It's not, so while the operator's precedence is lower, it is lower. Okay, then we pop item off the top of the stack. So then we pop the divide sign off there, which is good, and then we push the plus onto the stack. So I'm going to rub that out because it's gone, and that would be replaced with a plus sign. Okay, so that's good. We've now done the 3 and the 5 and the plus. Now the next thing it says is the 4. Every time we get a operand, that goes straight onto the new expression, and then we've now reached the end of that repeat loop. So now we're going to pop the stack into there. Now does that make sense what we have then? So the first thing we would do again is we would find the first operator from left to right. So we're going to do the 3 divided by 5, and then we're going to do the result of that. We're going to be adding 4. Now, okay. Now I'm going to show you an easier way to do that. Now, an easier way, if you don't want to do all of that, is this, right? All you do is, so let's do the first one again. So it's 3 plus 5 divided by 4. Let's make this full screen. Now, what we're going to do is those brackets there are kind of implied, and I'm going to put brackets around the whole thing. Now, all you do is move the operator to the end of their brackets. Now, this operator only encloses one operator in each bracket, so that one will go to there. That one will go to there. So that becomes 3, 5, 4 divide plus. Let's do the same one for this one. So 3 divided by 5 plus 4. Again, it's going to have a brackets there. I'm going to put another brackets in there. So that one will go to the end of its brackets there. That one will go to the end of its brackets there. So that becomes 3, 5 divide 4 plus. All right. So that's kind of an easier, quicker way of doing it if you want a really quick and dirty way of doing it, but it does work. Right. Let's go back to the PowerPoint now. Right. So how do we evaluate, if we've got a reverse Polish notation expression, how do we get the computer to do it? And this really illustrates the goodness of it. Now, it looks a lot more worse than it is. Okay, so easy to do with stack. Given a proper postfix expression, get the next token. If it's an operator, we push it onto the stack. Sorry, an operand, we push it onto the stack. So it's like 1, 3, 5, whatever. If it's an operator, we pop the stack to the right-hand operand, pop the stack again for the left hand, apply the operator to the 2 operands, and push the result back onto the stack. When the expression has been exhausted, the result is at the top and the only element of the stack. Right. So that looks a nightmare. So we've got 1, 2, 3, 4, 5 times plus 6 times plus. It's easy. Right, so what we do then is, if it's an operator, if you remember, we push it onto the stack. Sorry, I said that wrong. If it's an operand, we push onto the stack. So 1, 2, 3, 4, 5. Now we have an operator. So the 5 is going to go to the right, the 4 is going to go to the left. So we pop those off. We do the result, which is 4 5s are 20. So we push the result 20 onto the stack, and we carry on. Then we've got a plus. So we do the same again. Now you might think, why does that have to go to the right and that one to the left? Well, it doesn't make any difference for plus or timesing, but for minusing or dividing it would. All right, so we have to be consistent there. So that's 23, that's going back onto the stack. Now we get the next thing, which is just the operand 6, that gets pushed onto the stack. Now we've got a times, so we've got 6 times 23, which is 138. Then we've got another times, so it's 138 times 2, equals 276. Push that onto the stack, and we've got a plus, and the result of that goes onto the stack, 277. Now, that computer there didn't need to process the entirety of that string first to work out, oh god, what do we do first? It just uses a stack, so it just uses the stack for the operands, and when it hits an operator, it just evaluates that one thing and pushes the result back on the stack. Very easy for it to do. Okay, I'm not going to even look at that. Okay. So that is it's incredibly easy to do that. So let's just go back and look at this example here. So if we got this one here and we want to convert that in, so we have 3 and 5 get pushed onto the stack there. Then we have the divide. So it's 5 divided by 3. Okay, and that would get pushed back onto the stack. So it's 3 divided by 5. I'm not going to do the maths here, I'm just going to put that back on the stack. Right, next thing we do is we get the 4. So the 4 goes onto the stack, and then we got the plus. So the plus goes there, so it's 4, that's 3 divided by 5. And I end up with my original expression. Okay. Now, what you've got now to do is you have some exercises. These ones here. Now, first ones here, I just want to quickly go over some of these. How would the following infix be represented in postfix? Well, make sure, so that one there, again, you just put in the brackets, or you can go the long way around if you want to. That's big. And then, so that bracket's going to, that minus one's going to go there, that's going to go there. So that becomes 3, 4, 2 times minus. Okay. Now, one thing you've got to be a bit careful of is these ones here. They're number 3, so. Yeah, that's right. Now, so ABC star, so ABC plus minus. Now make sure that you don't rearrange that expression, all right? So if you imagine what it's going to be, well, we've got, it's going to do that first. But the A happens, so don't be doing B plus C and then go, yeah, okay, put that in brackets, and then times in that with A. All right, even though that would give you the correct answer, it's not in the order in which the operands were presented, if you like. All right, so what you need to do is A, B, C, stack it. Right, then we're doing so the plus is there, so we will be doing onto the stack, we'll be going C and B. All right, so there's my new stack. It's now B plus C. All right, and then we would then go, right, what's our next thing? We've got, so we've done the plus, then it's the times, so it's B plus C times the A. So that's going over that side, that's going over that side, all right? Now, because it did, it's not A times B, so it's A times the of B plus C, if you see what I mean. Well, I'm not explaining that too well, but you get the idea that that is the correct, only the right answer for that, nothing else. All right, so be aware of that. Okay, so that's reverse Polish. That's one that's a pretty good one for the exams, and we'll have a look at some exam questions as well.